Python file objects, closing, and destructors. The description of tempfile.nemet temporary file says, if delete is true, the default, the file is deleted as soon as it is closed. In some circumstances, this means that the file is not deleted after the Python interpreter ends. For example, when running the following test under py.test, the temporary file remains. In some way this makes sense, because this program never explicitly closes the file object. The only other way for the object to get closed would presumably be in the _del_destructor, but here the language references states that it is not guaranteed that _del_. Methods are called for objects that still exist when the interpreter exits. So everything is consistent with the documentation so far. However, I'm confused about the implications of this. If it is not guaranteed that file objects are closed on interpreter exit, can it possibly happen that some data that was successfully written to a buffered file object is lost even though the program exits gracefully, because it was still in the file object's buffer, and the file object never got closed? Somehow that seems very unlikely and unpythonic to me, and the open documentation doesn't contain any such warnings either. So I, tentatively, conclude that file objects are, after all, guaranteed to be closed. But how does this magic happen, and why can't a nemet temporary file use the same magic to ensure that the file is deleted? Edit, note that I am not talking about file descriptors here, that are buffered by the os and closed by the os on program exit, but about Python file objects that may implement their own buffering.
On Windows, nemet temporary file uses a Windows-specific extension, os.o_temporary, to ensure that the file is deleted when it is closed. This probably also works if the process is killed in any way. However, there is no obvious equivalent on POSIX, most likely because on POSIX you can simply delete files that are still in use. It only deletes the name, and the file's content is only removed after it is closed, in any way. But indeed, assuming that we want the file name to persist until the file is closed, like with nemet temporary file, then we need magic. We cannot use the same magic as for flushing buffered files. What occurs there is that the C library handles it. In Python 2, the files are file objects in C, and the C guarantees that they are flushed on normal program exit, but not if the process is killed. In the case of Python 3, there is custom C code to achieve the same effect. But it's specific to this use case, not anything directly reusable. That's why nemet temporary file uses a custom _del_. And indeed, _del_ are not guaranteed to be called when the interpreter exits. We can prove it with a global cycle of references that also references a nemet temporary file instance, or running PyPy instead of Python. As a side note, nemet temporary file could be implemented a bit more robustly, for example by registering itself with a texit to ensure that the file name is removed then. But you can call it yourself too, if your process doesn't use an unbounded number of nemet temporary files. It's simply a texit.register my _named _temporary _file.close.
On any version of Nix, all file descriptors are closed when a process finishes, and this is taken care of by the operating system. Windows is likely exactly the same in this respect. Without digging in the source code, I can't say with 100% authority what actually happens, but likely what happens is, if delete is false, unlink, or a function similar to it on other operating systems, is called. This means that the file will automatically be deleted when the process exits and there are no more open file descriptors. While the process is running, the file will still remain around. If delete is true, likely the C function remove is used. This will forcibly delete the file before the process exits.
The file buffering is handled by the operating system. If you do not close a file after you open it, it is because you are assuming that the operating system will flush the buffer and close the file after the owner exists. This is not Python magic, this is your OS doing its thing. The _del_ method is related to Python, and requires explicit calls.
If you want this a lot, please consider subscribing.